All right, lesson 4D is going to look at scatter plots. All right, and you've probably seen these before. They're just a bunch of different dots, and these dots represent data. So if we were plotting shoe size and height. So this person has a shoe size of 4 or whatever this is and a height of wherever that is on the y-axis. So just plotting two sets of data that are related to each other. All right, and when we look at scatter plots, we're looking at something called the correlation. All right, and the correlation is what is the relationship between the two. So this example right here is a positive correlation because as I go from left to right, the dots are going up. So that means that as my X values increase, my Y values also increase. So that would be a good example for like shoe size and height. As my shoe size gets bigger, my height gets bigger as well. Now, an important thing to realize about correlation is it does not have to be 100% true for every single person in the world. All right, there could be some people that their feet get bigger, but they don't actually grow. All right, but for the most part, as shoe size increases, height also increases. So that's a positive correlation. All right, this picture in the middle here is a negative correlation. So as the X values get bigger, the Y values get smaller. All right, so as X values get bigger, Y values get smaller. So an example of this might be the number of assignments not handed in and your grade. So as you have more and more assignments that are not handed in, your grade would go down. All right, and then no correlation is when the dots are kind of all over the place. All right, they don't really all go up, they don't really all go down. They're just kind of all over the place. They don't really have a pattern, and so that's no correlation. And when we talk about correlation, we're also going to be talking about something called the correlation coefficient, and the symbol for that is R. All right, so the correlation coefficient is R. And it is a measure of how strong the relationship is in a scatter plot. So, yeah, we could say the dots are going up, but are they all really close together and form almost a perfect straight line? Or do they just kind of sort of look like they go up? All right, so if it's close to 1, that is a strong positive relationship. So this graph might have a correlation coefficient of like 0.9. All right, it's really close to 1. That's almost a straight line going up. All right, close to -1 is a strong negative relationship. So again, this graph might have a correlation of -0.9. All right, because the dots are almost all on a perfectly straight line. Right? And this would have a correlation coefficient or an R probably somewhere really close to 0 because there's not really a relationship there. All right? So correlation coefficient is always between 1 and -1. We can't have an R of 1.4. All right? It's always between 1 and -1. And the closer it is to either of those values, the stronger the relationship is. So like if we get a 0.6, 0.7, 0.8, that's a really good correlation coefficient, all right, and same thing with -0.7, -0.8, those are good as well. When we're close to 0, 0.1, 0.2, 0.3, those are weak relationships. Okay, so here's an example of the type of problems we're going to do. We're given some data here about the years since 1988 and the largest vertical drop in a roller coaster. All right, and so we're going to look at this data, see what kind of relationship exists, and then see if we can use that relationship to make some predictions about the vertical drops in the future. Okay, so we're going to do this on the calculator, and I'm not going to walk you through the steps in the video. You have them on the calculator sheet that I gave you, and we're going to do it in class, but I am going to show you what it looks like and look at the rest of it. So make a scatter plot. The calculator will actually do that for you. So I've gone ahead and gone through this process, and we'll do this in class, but I put these numbers in, and the calculator made a scatter plot for me, so that's what it looks like. All right, so describe the correlation. What kind of correlation do these points have? Well, as I go from left to right, it seems to me like as x gets bigger, y gets bigger as well. So I would say that these have a positive correlation. All right, we can actually use the calculator to give us a line to describe those points. So we can get it to draw a line that kind of matches as many of those points as possible. All right, so when I do that, and again, we'll go through this in class, but it gives me a whole bunch of numbers. All right, it tells me that y is equal to 13.95. that B is equal to 127.41, all right? And it tells me that, if you look down here at the bottom, the equation is y equals ax plus b. So when we're doing line of best fit on the calculator, a is also m, or the slope. So if I write the equation, it's y equals a times x plus b. All right, and this is an equation that can be used to predict the vertical drop of a roller coaster. All right, whenever we write an equation, we want to look at r, because r tells us how good our equation will be at predicting. All right, and the calculator will give you r as well. So here I have r equals 0.89. All right, that is really close to +1. So that is a strong positive relationship, all right, or positive correlation. Okay, and we would say that this equation is a good model, meaning it really closely predicts the vertical drop of a roller coaster. All right, and what we would do then is use this equation to predict numbers that are not in our table. All right, so it says, what would the vertical drop be in the year 2014? All right, I have year since 1988 in my table, which means that this one actually means 1989 because it's 1 year after 1988. All right, so my table goes up to 15. 15 years after 1988 would be 2003. But the question wants to know what would the vertical drop be in the year 2014. So that's where I'm going to use my equation here. All right, and generally, what we put in list 1, all right, what we put on the x-axis, and then what we put on the y-axis here. All right, and so this is the independent variable. You should remember this from like science class in middle school. All right, independent and dependent variable. So independent variable is years, dependent variable is height. Okay, and I'm going to use that to predict. So 2014, how many years after 1988 would that be? So I've got to do some subtraction first. 2014 minus 1988 is 26. So I want to know what would the vertical drop be 26 years after 1988. And because years are my x, my independent variable, I'm just going to use this equation and plug it in. So I have y equals 13.95 times 26 plus 127.41. And when I do that math, I get 490.11. So according to our equation, we are predicting that in 2014, the vertical drop for the roller coaster would have been 490 feet.